as some of you may recall, in 2020, uh, the global supply chain shattered, and you couldn't get medical supplies for love or money in just about anywhere. And the good news is that a lot of folks stepped up to try to fix this problem. Engineers all over the world were like, I will design a 3D printable thing that will help. We will make open source ventilators and masks and face shields and so on. Um, but this didn't really solve most of the actual problems. Most of the actual problems were much more mundane and unsexy and far more important. Uh, you know, the the vast majority of effort of people who are actually trying to get these things made and distributed went to manually solving coordination problems. And I spent a lot of time working closely with helpful engineering and open source medical supplies, both of whom are represented here, um, trying to kind of orient this as an infrastructure problem. Um, you know, it is now 6 years later, and we are, if anything, less well prepared for the next catastrophe than we were for the last one, and seem to have, as a nation, learned a negative amount of lessons uh, from all this. So the the systems that we had to sort of slap together on the fly in 2020 as a way to deal with a crisis are absolutely going to be necessary again. Um, and so that's why basically for the entire time since 2020, I've been working with helpful engineering to try to build a system that can automate some of these uh, sort of these foundational challenges. Um, let's take a step back because I know some of you are coming into this without a lot of context. So let's try to sort of set the scene. And I'm going to describe to you some of the situations that we dealt with. This isn't, we won't get into an exhaustive list because there will be like a tech demo of the thing that we've built, and we'll talk about what's actually working now and what's still in development and how you can get involved and so on. But I just want to like tell a story, try to set the scene. I know some of you were there. Please feel free to pipe in if I'm missing important details. Um, so, you know, open source hardware in crisis response is a great idea, in practice is very difficult to pull off, um, especially when what you need is more complicated than a single thing that can be 3D printed. Uh, you know, which there's a handful of useful little things that you can do with that, but most things are a little more complicated, and especially when it comes to medical supplies, the the risk of designing it incorrectly is very real. There were a lot of uh, open source ventilator designs going around in the early days of COVID, as people were like, well, you can't get ventilators, so we'll just design one. And thankfully, most of these were never used because they would have killed people. Uh, there was maybe one or two designs out there that wouldn't have blown up somebody's lungs. But if you were trying to find one to build in order to keep a relative alive or whatever, you had no way of knowing. So you had this problem of being unable to vet designs, unable to know which ones were tested. You had the problem of not being able to discover existing designs. So everyone just jumped straight to prototyping a new thing. It was easier to start something from scratch than it was to find a thing that existed and improve on it, even if everything was open source. Uh, then you had the manual coordination problems. Um, we just had it. So Antonio, welcome. Nice to see you. Uh, for those who are joining a little late, just to catch up, I am kind of setting the scene and talking about how all this kind of came to be and why it's still happening. Talking about 2020 COVID supply chain breaking down and some of the challenges that a lot of us faced trying to solve these problems. So you're joining in a story, but we'll get to the technical demo in a little bit. Okay, so um, you have the problems of, you know, discoverability. Uh, as a Victoria was saying a minute ago, one of the big problems was just simply coordination. There were thousands of volunteers across dozens of organizations just within the US, several all around the world, doing similar things. And it seemed to me, like I don't have hard numbers on this, but my sense of it from being in it at the time for quite a bit was somewhere between 60 and 75% of everybody's effort, of all of the volunteer hours, went to manually solving coordination problems, to just, you know, reading emails and Facebook messages and talking to people and filling in spreadsheets to try to say, okay, well, this place has these things and those things need to get made over here. Um, and it was, you know, as anyone who was working at the time can tell you, it was painfully inefficient and deeply frustrating. And to watch so much brilliance and enthusiasm and effort solving the most fundamentally basic things. Um, and part of the challenge is that, these are, if you are operating within a closed source commercial ecosystem, these are solved problems. You have SAP, you have, you know, all of these tools that exist for this. But those tools only exist, if you can spend the $20,000 a year license for the software and everything is already kind of wired in. Uh, but what we're really trying to build is a supply chain mesh network. And that is a very different proposition. And it rests on the open source hardware community solving some problems that have been well solved in the open source software community for quite some time. Uh, and so the thing that we are talking about today is our attempt to solve that problem. Um, I've been talking for a bit. Uh, Before I get into kind of technical details and so on, uh, does anyone have any questions? Or is everyone following so far? And I apologize in advance if I'm a little out of it. This is very early for me, and I have not slept a ton. Uh, Great. Okay, thank you.
Doing good, Nathan.
Thanks, Victoria. Okay, so we've set the scene. We've talked about some of the challenges faced when this happened last time. I think most of us can agree, at least, that you know, this is probably going to happen again. Um, so what are we talking about with the supply chain mesh network? We were talking about these ad hoc processes. Um, Leopold, I see that I have a question. Andrew, I'm going to need you to answer that. Um, so we're talking about ad hoc processes of discovering open source designs that are available, or contributing to them, of discovering places, production facilities, maker spaces, small factories, etc., where things can be made, uh, and saying, okay, this is okay. So this is coming back to the Internet of Production Alliance. Part of the work that we've been doing, in conjunction with, you know, Open Source Hardware Association and uh, Losh and Helpful Engineering and a number of others, is at the sort of foundational level, universal open hardware data standards. Uh, Deeply unsexy work, but very necessary for infrastructure. At its heart, there are sort of two interlocking standards. There's open know-how and open nowhere. Open know-how is meant to be uh, a data standard for encapsulating every possible thing that you need to know about building any arbitrary object. In practice, these are not things like a fighter jet or anything that's, millions of parts with supply chains 3 countries long. This is generally for things that could be built by a person in a place. But you up to medium complexity realistically. Um, and then open nowhere is that sort of, the matching or interlocking piece that says, what is a given production facility capable of? Is this a garage with a 3D printer? Is this, a high precision CNC shop? Is this, printed circuit boards, et cetera? What can we do? Uh, and the idea is that with this information and a little bit of automation, you can solve like 90% of what we spent most of our time in 2020 trying to solve by hand. Um, I have put together a demo of the tech that we've been building over at Helpful Engineering based on this. And we'll get to it in a little bit, but like the spoiler is um, what I show is you can say, all right, for this given design, show me all the places that can make it. If it is a complicated design that has a number of subcomponents, you can find a nested solution that says, okay, these six facilities in aggregate can together produce this one object. Um, and once you know, find the solution that can produce the thing that you want, you can automatically generate an RFQ, a request for quote, and send it out to all of them. Um, I wish that we had had this in 2020, and that is, the like that question of what did I wish that we had had back then has been, one of the main guiding principles of building this whole thing. So, all right, so we've got these data standards. Uh, those have been around for a bit, but in and of themselves, they're kind of useless. No one's going to interact with a data standard manually. Um, and so the approach has been this sort of layered model. At the bottom, you have a data standard. On top of a data standard, you build tools. And by tools, I mean like very low level, simple tools. If anyone here works on, a Linux command line, tree is a tool in this case. Like something just, it does one thing, it does it simply, it does it well, and it can be, combined with other things. Uh, the next layer up is an engine. You roll up a bunch of tools into a single entry point that says, all right, here are all of the tools that you need in order to interact with this system in one convenient place. Uh, Once you have an engine, then you can start building services. That's where you can have something where like someone doesn't need to talk to the engine directly. They can, send a call in via API, get a response back, and kind of go on about with whatever they're doing. And then finally, on top of that, you have a platform. What we have today is an engine. There's that is close to being ready for services. You can run it. I actually have it currently running as a container in Google Cloud, but you can run it locally very easily. You can run it as a command line tool for dealing with manually, and it will wrap up all of the things that we'll get into what it does in just a moment. But you can also run it as a server, and everything that it does is exposed via API endpoints as well as command line interface. Uh, so you have options as far as how you want to interact with it. And of course, goes without saying, but this is all completely open source. We welcome contributors and collaborators and, people who have ideas about how they can apply it. We would love to support that. Um, Sorry, what is this? Comment from Lawrence. Bigger problem in making open source designs and projects work better. Blah, 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 blah. Um, Excellent. Yeah, I would love to hear more about what you would like on the manufacturing side for this to work better. Let's definitely be in touch. So, okay, we've we've been telling stories and kind of setting the scene. I think this is probably a good place to do a quick demo of the tech. This interface is something that I slapped together in a couple days for this demo. So this is like the tool itself, the Open Harbor Manager is a backend service. So anything that you're seeing here is really just a thing I put together for the demo. So apologies in advance that it's rough. Um, the for the purposes of this demo, this is synthetic data. It is using the real data standards, but I'm not like trying to pull from a map of like makerspaces. Um, so the real key thing that I wanted to get in here. Okay, so we've got a bunch of designs in here. So we're going to pick some that's IoT sensor node. This the notion here is to uh, show that like we'll get into the nitty gritty and the details of these like what a real one looks like. But for the purposes of this demo here, we're saying okay, we have this, we've selected this design, uh, and we're showing that we with something that has multiple components. Where not say in this case need a custom PCB. You have a 3D printed enclosure. We've got final assembly. We're going to assume that no one place can do all of these things. Simple one-to-one matching is trivial and also not typically how things work in real life. So for the purposes of this, we're going to say, all right, if I need 100 of these made, uh, show me, show me places that can do it. Uh, Now we'll get into some of the other stuff that can happen here, but I wanted to just sort of uh, show a bit of what's possible. So this is what the system is doing here is it's crawling through all of the all of the spaces that it knows about, looking at the things that they're capable of based on the tools that they have listed and processes that they're capable of, et cetera. Um, the nitty-gritty of how that happens is more complicated, and we're going to get into that at this next thing. But I wanted to start with something visual that is probably easier to relate to than a bunch of code on a screen. Um, so here we see, for the specific components, here are places that can meet it or meet the requirements of those components. And here's how we kind of wind up with a solution. Uh, Here are 12 different sort of solutions that give us like, all right, this is, these are valid, these will work. Uh, Here's our sort of plan showing in stages, and then we say, okay, well, you know, let's generate the RFQs necessary so we can get this sent out. Um, and then next one, etc. So, obviously you can do a lot to like adjust the level of detail and manage some of the things in the ways that you would need it so that we're not automatically sending it, but generating it on the fly based on what's needed and the place that you're matched to. Like this thing that just took us 30 seconds to do was hours and hours. Victoria can tell you how many hours she spent trying to just manually solve this problem. A lot of us did. And so for the when the next time this shit happens, something like this will hopefully be in place and we can be working on this together uh, in a way that will actually save some of the lives that we were trying to save last time. Now, uh, I want to get into kind of the nitty gritty of what like this system can actually do. Um, but are there any questions about that quick demo before I move on to the next thing? Okay, cool. Feel free to pop up in the comments if you have anything. So, wait, that's the wrong one we're looking at. This is a different open source project. Let's see. We want to share the other thing. Here we go. Okay. All right. So first, let's just kind of do a high level overview of like what are the things that the Open Hardware Manager can do. If anyone is used to working on, if anyone here is a professional computer toucher, you've probably interacted with things like npm or pip, which are package managers. And to some extent, this is kind of trying to be a package manager in the vein of npm for hardware. Um, it does a number of things, but that is a big part of it. So uh, what we saw in the demo is the primarily the matching component of this, where you say, okay, given requirements, as represented as an open know-how file, uh, what are the capabilities that match it? So we can find places that will do this. Um, the next two, generation and scaffolding, are interesting because you know, the thing about a data standard is no matter how great it is, people are already using whatever they were using before. And you need to give people an easy way to enter into your system. So scaffolding is if you're operating greenfield, you want to start a new thing and you want to make it compliant with this structure, you can just say, okay, you know, OHM, OKH scaffold. It will give you a sort of pre-built empty directory structure where like here's where you put the design files, here's where you put the manufacturing files, here's where you put the instructions, here's where you put all these things, and they're all automatically linked to each other, and the documentation is kind of scaffolded for you. Generation is when you have an existing project and you want to convert it into this system. Uh, this is actually, I have a demo of this that I did recently on a fairly complicated project that we will get to in a moment, but it actually works reasonably well. Um, this file here, which is a few thousand lines, um, this is all generated automatically from that command based on uh, simply passing it the GitHub repo of a project that has nothing to do with open know-how or for this demo. Um, and while it's not perfect, it's pretty good. Um, let's see. So gen generation and scaffolding give us some easy entry points into using the system and kind of bringing people in. In addition, there's a utility for kind of fixing and validating. Okay, well, actually, let's get into the OKH management because that's all in there. So, open know-how is that sort of foundational data standard that makes all this possible. So you can, create, read, update, delete, validate, fix, extract requirements. If you have an OKH and you're like, okay, well, what are the actual requirements needed to make this? I'm not going to read the whole thing. You can say, okay, well, what you need to make this is, fuse deposition, filament, production, and PCB printing or whatever. Um, Similarly, same set of functions for managing OKWs. Uh, then there's the package management itself, which I am pretty pleased with. I think this can potentially solve some big problems for us in the future. So what do I mean with package? So the important distinction when getting into this stuff is the difference between a manifest and a package. A manifest is this flat JSON file, like we were just looking at. And this says, here's all of the things that go into this, but it's not the things itself. This requires a bunch of STL and files that need to be printed in order to actually make the thing. And those are heavyweight files that exist somewhere that's not in this JSON. Um, so the manifest is, here's all the things, here's where you find them. A package is all of those things gathered in one place. So uh, when you say like, okay, package build, for example, and then point it at a manifest, it will build, if you can see here on the left here, everything in here, all of these folders full of all the files for all of the parts and all the various bits and pieces that go into it. Uh, all of that is populated by crawling the manifest and saying, okay, everything that has a link that has a path, pull that down, put it in its right place. Uh, and then now you have, okay, here is the package. Here is literally everything I need to make this all in one place, and it's versioned. So you can say, all right, you know, uh, actually here, I'm gonna do, where did I put it? So, locally we have this one package. Uh, but up in remote storage, we have these four. So like the open flexure microscope. And if I just said, if I wanted to say like, oh, cool, the microscope is available, package, pull, microscope, and then I could just everything I needed for that design, just pull it down to my local system, boom, ready to go. Similarly, this comes back to one of the problems we talked about earlier, where you have a lot of designs out there and you have no way of knowing if they've been vetted or tested. And because a design is spread across so many different files, uh, you often run into this problem of saying like, okay, well, you know, theoretically this design can, be used safely in a medical context, but which version of it and which version of which file, uh, and it becomes very difficult to track and there's a lot of risks to it. And so part of what we're trying to solve here is you can say, okay, you know, this entire package as a set is versioned in this specific version, and this version has been tested and found to be safe. So you can download that specific version, and you'll get the files that correspond to it. Sorry, see, I missed some questions here. Let me try to respond to this briefly. Um, See, Leopold asked about OHO. I actually don't know what that is. So not connected as far as I'm aware, but I'm curious to know more about that. Matthias, building open source PLM software. Blah, 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 blah. Yeah, okay, it's not really detailed enough for it. The new version seems complicated. Um, yeah, it is a challenging thing. I would love to talk to you more about that, Matthias, because I think the version of what we've got here is a little bit past OKHV1. Um, but yeah, there's a lot of problems. Once we get into I want to get through a couple more things and then we'll open it up to more conversation. Because we really want to get into this stuff. In the meantime, where were we? Okay. So back at the stuff you can do with it. Okay. So package management, we just talked about. Um, this tool does benefit from some LLM integration. It's not at all required. It is very much an optional feature. Um, and I'll explain what it's used for in a moment. But there's a number of features where, how to put it? Okay, to step back a moment, part of why, as I'm sure many of you are aware, part of why a lot of these problems are so difficult and so intractable is they are very fuzzy. There's a lot of, semantic noise uh, in the way that information is represented. There's no single standard way that everyone has all agreed on how to, talk about what tools or capabilities or requirements or whatever exist in a thing. Um, and so, frequently you end up just needing to have a person be like, well, as I interpret it, this is a valid match or otherwise. And LLMs can help with that. But obviously it's no good to design a system that depends on it. Um, so one of the things that I wanted to get at, part of how this system works, uh, and how the matching works and the generation and all these things, there's a layered system that I'm fairly pleased with having implemented uh, that helps address some of this and so far does a pretty good job at handling a lot of this inherent complexity. So basically, the notion is at the top you have a direct matching layer. This is simple one-to-one compare this string to this string, um, and this kind of helps you sort of orient to your fixed points. Any OKH is going to have a title. It's going to have a couple named fields that will always exist. And if they don't, then you're not dealing with a valid thing. But this is really just a minimal scaffolding to kind of orient you to some fixed points. The next layer down is heuristic. This is where you have rules for you know uh, synonyms and things that are of a related meaning. If you see 3DP, or 3D printing, those are considered the same thing, etc. This can the rules themselves are versioned and available and things that you can, they are config files that you can adjust. If the way that it's talked about where you work and live is different from how it's in here, it's easy to change. Um, but so there's this sort of rules-based comparison where you can define how things are matched together. Uh, the next, and so the idea of this layered approach is that each layer is progressively more computationally expensive, but also more nuanced and more capable of subtlety. So after the heuristic layer, you have an NLP layer, natural language processing. This is not using AI, but it is using vector embeddings, which are often found together, um, where you can convert a word or a semantic unit into tokens that are mapped in a vector space and find words that are in close to that word in the same vector space and say these are semantically related, even if they are linguistically distant. Um, this allows for a lot of this makes it much easier to, for example, like say you're trying to generate an OKH manifest from someone else's project, and they have described in the README the purpose of this project, but at no point is there, purpose colon phrase, but it can kind of pull that out of the content. And then the last layer, which is optional, is an LLM, which can, if it's enabled, if you have one set up, uh, can provide a lot of additional quality control, and help pick out things that are maybe a little bit more subtle. I found that it's improved the quality of the results a lot if you can use it, but again, it will work without it. Uh, and this sort of four-layer approach shows up in both the matching process, generation process, and a couple other places. Uh, let's see. Validation, pretty self-explanatory. Um, a supply tree is a notion that we came up with at Helpful Engineering as a way of kind of describing a valid solution to the matching problem. Uh, you know, it can get a little complicated to deal with, especially in nested solutions where you're saying like, oh, well, we need, a combination of six facilities to produce all the parts and then bring it together. And so this set of tools is designed to try to, manipulate and work with those solution objects. Representing those in a way that's sort of parsable and legible to humans is going to be its own interface problem. Domain management, the domain in this case is like manufacturing or cooking. Both have very similar problems that function in slightly different ways, but a recipe and an OKH are broadly the same thing, just in different domains. Um, the assumption is that for the most part, this is going to be a manufacturing focused area, but uh, making it somewhat domain agnostic felt worth a little bit of effort. And then the rest are sort of utility functions. Um, let's see. So yeah, I think that's probably a good high level overview. Any questions so far on that? I saw some. Oh, here we go. Yeah, questions. All right, what do we got? Um, uh, Andrew says, does the four level approach render standards a bit useless? No, absolutely not. Um, uh, as I work with AI way too much to trust it. And in general, even if you are using AI in this, like the standard is the skeleton. It's the scaffolding and framework that everything sits on and still depends on. AI, if it's helping at all, is helping to how to put it. It is helping to fit unstructured data or differently structured data into the OKH structure, and to find matches between OKHs and OKWs at the sort of fuzzy, ambiguous edges. Um, if you approach it as just a purely deterministic process where you're saying, can this list of facilities produce this object, and you're just looking for keyword matching and saying, well, do they have this specific machine or this specific process listed? If not, oh well. You're going to get a lot of false negatives. You're going to get some false positives. So the LLM and the sort of NLP matching are designed to give you better results at those fuzzy edges, but the data standards themselves provide the frame for all of that. Um, let's see. The OHO that you guys are talking about looks really interesting. Um, I definitely want to check that out. Leopold, if you're down to speak about this in a bit, I would love to hear you talk about it. Um, Let me answer this question really quickly. So, a lot of these systems fall apart when they get handed to a manufacturer who recreates your documentation, won't push changes back up. Um, yeah, I mean, again, like how to put it? A thing. So I don't know if this entirely speaks to your point, though it is certainly a valid one. Um, I'm not trying to, replace or even compete with the kind of mainstream closed source manufacturing supply chain. Like nothing that uses this system, nothing that's built on open source is ever going to, compete on price point with something that's produced in a mega factory in China and shipped around the world. Um, the this is really meant to be used in crisis, in conflict zones, in places in the world that are outside of the normal supply chain, or in scenarios where the supply chain decides that it no longer cares about a certain group of people and they have to make do with what they've got. Um, so to some extent, if you were trying to deal with manufacturing in the day to day, this is probably not the tool that you need. But if you were trying to solve these problems in a crisis, if you were trying to stand up a supply chain from nothing or very little, this is what's here to help. Um, Lawrence, I don't know if that exactly answers your question, but I hopefully get some context. Uh, Matthias, this interacts with both. So as you can see on the thing, there's an API endpoint and CLI command for um, each function group. Uh, yeah, Eric, Q&A. Let's do it. I think I've walked through most of it. You guys have been very patient as I kind of talk about a bunch of this stuff. So yeah, Q&A. What do we got? Oh, quality assurance, not Q&A. I see. Uh, yes. Quality assurance. So actually, I think Robert Reed, if he's still here, can probably speak to that. He and Victoria, as I recall, have been working on a sort of a offshoot project that's focusing specifically on solving that problem. Um, it
Yeah,
is a,
global distributed tracking.
yes. Do you guys want to speak to that? You want to talk about Gasquas?
Victoria, would you rather take that question or would you like me to?
Yeah, I'm cooking at the moment, but I can start answering the question. Yes, global distributed tracking is a software platform built under the umbrella of the Global Open Source Quality Assurance System, which is a project of public invention. And Rob, myself, and Christina Cole from OSMS are the steering committee for GOSQUIS. And global distributed tracking is a free and open source software that enables closed loop tracking for products, information, and logistics. It is fully encrypted and it allows anyone who holds an object in their hand to discover the provenance or the history, the life cycle that the product has been through, to be discovered if you scan a QR code. And no authentication is required because it's built on the standard of if you hold that object in your hand, you deserve to see what has happened to that object based on the entries that the life cycle managers of the object have added to that provenance. So we have this being used for manufacturing production line management, which includes quality assurance. And um, with DMDM, which is a open source manufacturing collective in Arizona, GLIA, which most everyone knows, is a medical solidarity company in Canada, and MSF in Africa is a new user of this system. Because there's enormous interest to end-to-end track, especially in additive manufacturing, the quality of the production and how we can communicate with the end user, which GDT allows in a very easy format. And it also allows certain regulatory compliance points to be met by using that system, whether you're working with the EU or the US. That's kind of it in a nutshell. Happy to connect more with anyone offline about it.
Thanks, Victoria. Appreciate it. Glad you were here for that. Eric, it looks like you found the right repo. If anyone else is interested, it is linked in the comments. Uh, Andrew, you had a question. What would this mean for manufacturing bureau companies like Fictive or Xometry that have spent a lot of time developing their manufacturing networks? Um, I don't know. It has some interesting potential. I'm not entirely sure. Um, I think there's how to put it. For bureaus like that, I think there's if they are open to it, it'd be some interesting diplomacy could happen with them about setting up, entry points into their entire network. Uh, but that is some long-term relationship building. And I'm not really sure where to start with that. But if anyone knows folks who work there, that would be a
And then
great
I've
conversation.
spoke both with the CEO of Xometry and there's another major contract manufacturing uh, firm. It's
Oh yeah, is
eluding me.
Fictive still around? I think they might have closed.
Oh no, I think Xometry's still around. Um,
I said Fictive is the other one.
yeah, it's not. It doesn't matter. But I've spoken with a number of the folks in these categories, and they're interested. Um, but they basically have the same process internally.
Hmm.
So they sort of a weird relationship with them. Well, the place we need to get to is a simple product that we can push at them
Hmm.
and get a sort of test of the processes.
Hmm.
Um, and there's a whole API problem with, they're expecting things formatted in a specific way. We
Hmm.
have our own formats. You're getting that
Right.
stuff to actually work. That's the whole trick.
Got it.
But
Okay.
I
I
see
mean,
that as something we should do in the future.
yeah, I think so. Um, yeah, maybe as the open hardware engine becomes a little bit more mature, we can figure out a way to get those two things to talk to each other. Um, Matthias asks if this is something that would be, um, centralized or distributed. Uh, so it's an interesting question. The model that I have been really trying to, the model that I've had in my head as I've been designing this is more of a mesh network than something central. Um, Eric and I and some other folks had a conversation last year about how we might set up something like a supply chain mesh network in a conflict zone, um, where there's no like where the internet is down, and like how would you mix actual mesh net network technology with something like this, um, you know uh, like but that said, it is flexible enough you could run it either way. Like if you said okay, here we're just going to run this server uh, of the Open Hardware Manager, and this is going to be the central one, and everyone can just point their systems at you know, this URL and send their API requests and get responses back. It would work. Um, but if you're not on that network, or if you don't want to run it that way, or you want to run your own, local network on your own, on your own mesh, that's fine too. Um, it is designed to be very flexible. So right now for discovery, the system is configured such that uh, you can store data on any of the big three cloud providers or locally. And it'd be pretty easy to add some other kind of some alternate storage solutions. So there's a bit of a storage abstraction layer that kind of sits between the system and the storage provider. So right now like this, all of this data is currently living on Google Cloud, but you could run it on Azure, you could run it on AWS, you could run it on your own server as long as you can, as long as your system can connect to it. Um, the problem of discovery and of deduplication and of networks kind of it's like say you have multiple networks that all join the same mesh, and they've each got overlapping but not identical sets of designs available to them. Uh, the the sort of like This problem is relatively well solved in some like network circles where you have like gossip protocol, where you have each node sort of checks in with other nodes near it and compares what they've got, and then says, oh, okay, well, if the goal is for all of us to eventually be consistent with each other, I'm going to say, all right, here's a hash of the things that I have on my network. Compare that to your hash. Okay, we can see that there's differences. And then you can kind of figure out what those differences are and synchronize them. If you're familiar with Merkle trees, this is a commonly used structure for handling this very efficiently. So even on a mesh network where you have kilobytes per second of data transfer, you can still synchronize the lightweight manifests very easily. And then when you need a full package, you can use something like a BitTorrent protocol to kind of pull that from everybody who's got it down to your wherever you need it locally. Does that make sense? I'll take that as yes. Um, any other questions or anything else that anyone wanted to bring up? Yeah, my hope with this is that people will want to, get involved and contribute. Feel free to unmute yourself and pipe in. Like this, we can have a conversation at this point. Robert, yes, what's up?
Oh, well, this may not be very helpful, but I'm strongly supportive of this effort. I think it really is kind of cracking open a problem that could be addressed. But the thing is, if you think about logistics, not about the material, but just the logistics of people, what we really need is more people working on this project, right? We need more people using it. Um,
Hmm.
Helpful Engineering has one really good worker, Namesha Kahinga, I think is her last name. But other than that, the only people working on it are Nathan, myself, and James. And I think Nathan has made a real innovation here, but it won't matter unless we can somehow field a team, not necessarily of people to help Nathan, but just people to use it. Like using it is equally important to um, making improvements in it. And I personally don't know how to do that, but if the people on this call can somehow think of a way to you know, build a user base for this, I think that would be the best thing that we could do.
Thanks, Robert.
One of the first things I would do is have MSF put their system into this because they have nodal additive. I hesitate to say manufacturing, but they have sophisticated nodal additive makerspace type setups in
Hmm.
their program 3D printing for all. And they have a design catalog that someone can pick a design, they attach a GDT to it. When that's picked, GDT follows the product through its production life cycle, and then people there's building out a sophisticated system where people can request, and so it's like external requesters and internal QA management, just to put it very loosely.
Yeah.
So a solution like this is useful when people are already familiar with it.
Hmm.
So when crisis comes or we're in a really restricted environment, we're not learning a new system. So um, if this allows API calls, then I don't see
Hmm.
any reason why MSF couldn't hook into it.
That would be amazing. I would love to get connected with MSF.
Okay.
Is that a connection that you can help facilitate?
Yeah, I'll send an email today. And Andrew, I agree with you. We should run some pilot programs. And pilot programs are things that can be funded.
Hmm.
You know, personally, I would like to see some pilot programs on this maybe before we pushed it on MSF in the sense that it's still kind of green and unused.
Yeah, that's fair. I mean, I suppose it
Yeah,
depends on who we're talking to there and what level of production readiness they need.
yeah, and whether they'd maybe be prepared to run it as a sort of small scale pilot as well as a test thing rather than saying we've got a finished system for you. Hi,
Right.
sorry,
Yeah,
hi
exactly.
Nathan, and
This is
hello
fun.
everyone. Yes, I'm sorry. I've been moving between train stations in London during this call, so I've not heard every detail, but from the gist of it, of what I've heard between that, it sounds brilliant and it sounds really interesting. And I think, Nathan, we've been kind of looking at this thing of like resilience of maker spaces as well. So that's fantastic. And so I just want to say, yeah, thank you for doing this. I'd love to kind of, um, I think also pick up from the session that we did at the end of last year, and that sort of thing. But for now, I'm just hoping that there'll be a recording of this that I could watch where I could actually see it, and also if there's any like links to seeing any like whether the actual system or even if you're just doing some blogs or something on it, that would be great if you could share as well. And
Yeah,
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 and
of
all the
course.
best and happy New Year.
Thank you, Susan. Likewise. There is a recording which should be available to everybody after the call is over. But also, you have my number on Signal. Feel free to reach out, and I can, I can walk you through the tool and kind of show you where it's hosted and it's all documented, everything like that. So I'll make sure that you have what you're looking for. I haven't done a blog or anything about this. I haven't blogged since the days of LiveJournal, but I probably should do something about that. Um,
Or whatever your preferred format is.
yeah,
Yes.
yeah.
Do you want to do a little
Excellent.
TikTok, whatever?
No, I don't do TikTok. I'm an adult, which means I watch TikTok on Instagram. No, I'm yes, thank you.
So,
Um,
so I see an offer from Eric to trial this in Czech, which
ooh,
is a really great idea. Um, Rob, regarding MSF, MSF's system is so early and is very detailed. A lot of the details that we see here today are already included in their early nodal management system. I think it's worth having a conversation because Sylvester can tell us whether they're ready to participate in something like this or not. Um, and then we can go from there.
okay, great. Yeah, let's do that. Um, you know, 'cause if it's something that where their system is also still kind of coming into being, and we can kind of co-evolve and like adjust this to be, you know, the thing that they need, that would be amazing. That would be ideal. I'd be happy to put in whatever hours it takes to, you know, get this to be the thing that will solve real problems for MSF. They're one of the better organizations out there. Um, Similarly, it sounds like there's a lot of folks have contacts in various aid organizations that might be interested in stuff like this. So, you know, um, maybe what would be helpful is after this call, and we're just about out of time, but after this call, I can send out an email to everybody, start a thread, and if you can think of people who are like, oh, so and so is a person at this organization that you know, might be interested in using this or starting a case study or contributing or whatever. We can kind of pool all those resources together. That'd be great. Let's see. Um, cool. Are there any questions that I haven't answered or anything else anyone wanted to say? I know we're about at time. Um, well, uh, let's see. Leanne asked, "Can this be applied to open biological ware?" Can you elaborate on that? I'm not entirely sure what you mean.
Yeah, I guess I'm part of a group called Grow Good, and we look at blueprints and recipes to, trace food systems
Hmm.
in
Interesting.
agriculture and farmers, fork to farm,
Yeah,
farm to fork.
right. Um, Potentially. I mean, so as I mentioned earlier, there's this notion that the core functionality is domain agnostic, and that you can, the notion of domains within the system is extensible. So right now it supports manufacturing primarily and then cooking sort of secondarily. Um, if you could specify what a agriculture domain would look like and the kind of problems that it would need to solve, extending this system to support that is definitely possible. But as it's not a domain that I'm super familiar with, I would need you to kind of provide me those requirements, if that makes sense.
There's a bionutrient institute that shows that the nutrients in the soil is what creates the nutrients in the plants, which
Sure.
creates the omega-3 or 6 in the beef,
Hmm.
and therefore what's on your plate. And
Hmm.
there's recipes all the way along there that people are trying to put together so that people can do regenerative farming or
Interesting. I mean, it's like regenerative agriculture is something I would love to support. Um, if you or someone that you work with can get in touch to like have a deeper technical, like I could have a more technical deep dive about what that would entail. I'm happy to talk to you about it and see if it's something we can support.
I'll put you in touch with the person.
Thank you. Appreciate it. Um, uh, Matthias, you're talking about chaos in Europe. Do you mean CCC? Which chaos are we talking about? Oh yeah, CCC is great. I was bummed I couldn't make it this year. But yeah, no, I would love to get this in the hands of a bunch of hackers to, share designs and do interesting stuff with. You know, if you know anyone there, you think would be interested, please feel free to put me in touch or just point them at the repo. Um, what's an ERFA? Got it. Um, Eric has an interesting question about how do we keep facilities anonymous in a crisis, uh, which is a great question. Something I've given some thought to. And I have some ideas about how that could be implemented. It's not currently implemented in the version that we have right now, but it is a problem I'm aware of. Um, I mean, I think there's, and there's the, sort of the broader conversation that like the system as it's designed and as we've discussed it functions on the assumption that everyone interacting with it is doing so in good faith, which is not a reasonable assumption that we can make in the world as it exists right now, unfortunately. Um, and so, you know, thinking about how to sort of harden the system against adversarial actors, against people who are, going like, say, for example, you set this up in Ukraine to start producing 3D printed tourniquets, and you know, Russia goes like, we will place an order for 5,000 tourniquets that we never intend to fulfill, and it will jam up the system and like, do all this stuff. Um, there's these are absolutely problems that need to be solved. And uh, I have some thoughts on it, but it is a bigger problem than I can solve by myself. So maybe some of these European hackers who want to help me think about the security implications of building the system would like to get in touch. Um, Production communication would be out of band. Um,
Hello.
hey, Antonio.
Hey, Nathan. Hi,
Hey,
everyone.
hey.
Um, Sorry I was away from the call for a minute. I missed the point of how to deal with anonymous locations.
Hmm.
Um, yeah, I was in that kind of idea before I left the call.
Hmm.
Very important that during a crisis and
Yeah.
geopolitical tensions,
Yeah.
we have some sort of layer taking care of how the information is used because
Hmm.
it can be used um, yes, for benefit and also in the opposite way, I guess. And the I think that it comes. Yes, we need to harden the system. Like
Hmm.
there needs to be some sort of encryption and data. Um, to say, um, there needs to be a layering of how much of the data you can access, and
Yeah. Yeah, exactly.
also a constraint in your location.
Hmm.
Um, but also on top in the usability as an user, I guess defining well the roles that will of the people that will interact with the data will also help in the control of how the data is used. Like um, some of these may be um, like have a designated like a guardian, like let's say a data responsible person by and this maybe a way of making community. The last thing I hear was like, how do we make more community to use these systems
Hmm.
right now? Um, I agree that having the use case as a risk tool or disaster recovery tool is a little hard because it means you will have to have a very polished system and like someone mentioned too, it requires that people is already familiar. Uh, so it's difficult to test in these conditions, and I agree that having small pilots in different locations and um, will be important. And that in that way,
Hmm.
um, I'm thinking one of the niche we can connect with is um, climate change management. There are some organizations we met in previous years that work organizing people and in a way that they are aware of the measurements to control the environmental impact of their activities or remediation of some of the um, like the effects of others in their
Hmm.
own environment, like
Hmm.
for example organizing people around how to recycle plastics in Iraq or uh, in places where there is no recycling at all, and
Hmm.
or uh, in the beaches, like how we do use the plastics that are there mixed with uh, the sand and things like this. Like I see communities going around this, and I think that's a good niche in plastic recycling.
Hmm.
Um, and in regards of uh, developing things for biomedical purposes, uh, that's a big one. That's a more complicated thing because there are many constraints and layers on
Yes.
the the validation of these devices to be used on the medical field, I guess. The open flexure itself doesn't have still like a sort of validation to be used as a medical device yet. We are working on that.
Hmm.
Julian and
Oh yeah, the
Richard
open
are
lecture
working.
project is great.
Sorry?
Sorry, I was just agreeing with you. And yes, the open lecture microscope project is a great one, but I know it's a very uphill battle to
Yeah,
get certified.
yeah, yes. So I guess going for where communities are already active and
Hmm.
projects that will help them, that's a place to
Yeah,
go. Plastic's a good place, I guess.
I
Yeah,
agree. So I'm going to send out an email to everybody who showed up after this, uh, asking to, if you have ideas of like places or organizations that might be good to talk to about piloting use of this in one way or another, toss your ideas in. Hopefully, we can kind of get people connected. Um, yeah, I think there's like the small scale pilots and the talks with MSF are kind of top of the list of things that we would like to be doing soon. Um, and I will collect all of the links that everyone has shared in the chat as well and try to sort of collate that to get the resource list started. Um, cool. Um, yeah, thank you guys, everyone, for showing up. This has been great. It's nice to see so many folks show up, some familiar faces and some new ones. Um, I've shared the link to the project if anyone wants to check it out. It is extensively documented. Um, and should be pretty easy to set up on your local system if you just want to play with it using the command line. Um, if you want to run it as a server and start playing with the API, also, comes up right away. Um, if you have any questions, feel free to reach out to me. And yeah, I'll looking forward to working with you guys on this and seeing where we can take it. Thanks, everybody.